Hi, today I will be talking about solving parallelograms. This is an application of the theorems that guarantee a quadrilateral is a parallelogram. First, I have here a quadrilateral hope. If the measure of OPS is 28, this is 28, find the measure of angle E. Angle E. Since we have here a quadrilateral, a parallel line, then this line is the transversal line. And angle E and angle P are corresponding angles. That means angle E is 28 degrees. Next, if the measure of angle HEP is 4x plus 17 degrees, then the measure of angle O is 6x minus 29 degrees. Then the measure of angle O is, remember that these angles are equal or congruent because the opposite angles of a parallelogram is congruent. So we can say that 4x plus 17 is equal to 6x minus 29. Solving that one, we have HEP is equal to 109 degrees. And of course, measure of angle O is 109 degrees. So we can solve that one by solving it algebraically. So we have 17 plus 29 is equals to 6x minus 4x, and 2x is equal to 46. Now our x is 23. But we will not end there. We will substitute x to the values of HEP, which is 4x plus 17, and for the value of angle O, which is 6x minus 29, and substituting it, we have 109 degrees. Next, what if the sides are given but in algebraic expressions, just like here, 4x plus 17 and 6x minus 29, but we are not talking about the angles. We are talking about the sides. The sides HO, the sides OP, the sides EP, and the sides HE. How will we find for the exact values of the sides? Still, we will apply the algebraic way of solving the sides. We will just equate this one. Remember that sides HE is equal to side OP, and side HO is equal to side EP. So we will just equate the two expressions. How will we find for the perimeter? Perimeter is the distance of all the sides, or the sum of all the sides of a polygon. So if you already found out the sides, the measures of the sides of your parallelogram, then you will just add all the sides, and then that's the perimeter. And remember, if the unit is given, answer in complete final answer with the units. What if the measure of angle E and angle P are given as algebraic expression? How will you find for their exact values? Okay, angle E and angle P are adjacent angles, and adjacent angles in a parallelogram is supplementary. That means they add up to 180 degrees. So if you are given with the measure of this one, you will just add. For example, we will use the same algebraic expression as 4x plus 17 and 6x minus 29. We add the two, and then since they are complementary, they equate to 180 degrees. And then you solve for x. And after you found for x, you substitute it to the expression that represents each angle. Let's try this one. We have still angle parallelogram hope with the diagonals intersect at point A. What is the measure of HA? So HA is this one. And remember that the sides of your diagonal, this one, HA and AP is equal. So we will just equate 2x plus 9 is equal to 15 plus x. 15 plus x, since they are equal. So we have 2x minus x, 15 minus 9. We have x is equal to 6. And then if we substitute that 6 to x, we have 2 times 6, that's 12 plus 9, that's 21. 21. So your HA is 21. Yes, since they are congruent. And what is the measure of angle HP? The entire diagonal, that's times 2, that's 42. Find x and y given that each quadrilateral is a parallelogram, or our quadrilateral EFGAD is a parallelogram. And remember the theorem for a parallelogram, that the opposite sides are congruent. So ED and FG are congruent, and EF and DG are congruent, and then we will find for x. Luckily, we have the same variable for our parallel sides. So we have our sides ED is congruent to our side FG. So we will just equate the two expressions. And then by finding our x, we have plus 12. 8x is equal to 48. And our x is equal to 6. And we will not end that there. We will substitute in order to find for ED. Well, let's just find for ED. 6 times 6, that is 36, minus 12, that is 24. So assuming, since we are only asked with x, so our x is equal to 6. And our y, we have our sides EF is congruent to side DG. So we have 4y is congruent to 6y minus 42. Equal. So 6y minus 4y, and then positive 42. We have 2y is equal to 42, and our y is equal to 21. So our x and y for this parallelogram is 6 and 21 respectively. Next problem, we will still need find for the values of x and y, but here the given expressions are represent our diagonals. So we have the measure of our QT line segment QT 5y, our line segment TS is equal to 2y plus 12, our line segment RT is equal to x, and our line segment TP is equal to 5x minus 28. Remember that diagonals bisect each other. That means our line segment RP is congruent. I'm sorry, that is line segment RT is congruent to line segment TP. So we have x is equal to 5x minus 28. That is 5x minus x. That is 28. For x equals 28. So our x is equal to 7. And then for the y value, so the second diagonal is represented with y variable. So we have QT, line segment QT is congruent to line segment TS. That means 5y is equal to 2y plus 12. 5y minus 2y is equal to 12. 3y is equal to 12. Y is equal to 4. That means the value of our x is equal to 7, and then the value of our y is equal to 4. If you are asked with the exact value of the line segments mentioned, just substitute the value of x to each expressions represented by that line segment. For example, TP, it's 5x minus 28. So you substitute x is equal to 7 to x in that 5x minus 28, and then solve. And then there you can get the exact value of the line segment TP. Next, PQRS is a parallelogram. Find for the value of x. So we have the measure of our angle S is equal to 3x, and the measure of our angle R is equal to 120. Without solving, we can say that the value of angle S is equal to 60. Why? Because adjacent angles are supplementary. That means if we will add angle S and angle R, they should be equal to 180. So if our angle S is 3x and our angle R is 120, and the total should be 180, so that is 3x is equal to 180 minus 120. 3x is equal to 60, and our x is equal to 20 degrees. 20 only because the given has degrees already. So our x is equal to 20. So that's it for solving parallelograms. I hope you learned something and you can apply what you learned to your activities.